The LA engines are a family of pushrod OHV90 gasoline engines built by Chrysler Corporation. It was factory installed in passenger vehicles, trucks and vans, commercial vehicles, marine and industrial applications from 1964 through 2003. The combustion chambers are wedge-shaped, rather than the polyspherical combustion chambers in the predecessor A engine or the hemispherical chambers in the Chrysler Hemi engine. All are cast iron, except for the Viper V10 which is aluminum. LA engines have the same 4.46-inch bore spacing as the A engines. LA engines were made at Chrysler's Mound Road engine plant in Detroit, Michigan as well as plants in Canada and Mexico. The L in LA stands for light, as the older A engine was nearly 50 pounds heavier. Willem Weertman, who later became chief engineer of Euro engine design and development, was in charge of the conversion. The basic design of the LA engine would go unchanged through the development of the Magnum upgrade and into the 21st century, although the finer details were changed to create a more powerful, efficient, and modern powerplant. 273 V8. The 273 was the first LA engine, mid-1964 and offered through 1969, rated at 180 bhp. It had a 3.625 in-bore and 3.31 in-stroke. It had a mechanical solid lifter valve train until 1968 when hydraulic lifters were introduced. Hydraulic lifters generally make for a quieter valve train. The reciprocating assembly included a cast or forged steel crankshaft, drop-forged steel connecting rods and cast aluminum pistons. The valve train consisted of a cast nodular iron camshaft, solid or hydraulic lifters, solid pushrods and shaft-mounted, malleable iron rocker arms. These actuated the overhead steel intake and exhaust valves. The cylinder heads featured wedge-shaped combustion chambers with a single intake and a single exhaust valve for each cylinder. Spark plugs were located in the side of the cylinder head, between the exhaust ports. A high-performance 235 HP was offered 1965-67, this was standard in the Barracuda Formula S model and optional in all other compact models EXC station wagons. It featured a 4-barrel carburetor and matching intake manifold, chrome unsilenced air cleaner with call-out sticker, longer duration and higher lift camshaft and stronger valve springs, 10.51 compression ratio, special black wrinkle valve covers with cast aluminum appliques, and a low-restriction exhaust system with a 2.5 inches exhaust pipe, collector type Y-junction, and exposed resonator. In 1965 the muffler was of straight-through construction. A special version was also available in 1966 only, it used a 0.500-inch lift solid lifter camshaft, fabricated steel tube exhaust, and a Holley 4-barrel carburetor, producing 275 horsepower. It was available in the Dodge Dart only, and the car so equipped was called the D-Dart, a reference to its classification in NHRA stock for drag racing, which was the car's only intended purpose. 318 V8. The LA 318 was a 318 equivalent relative of the A318. Like the A318, it has a larger cylinder bore at 3.91 in as well as a stroke of 3.31 in. It appeared shortly after the 273, in 1967, and proved tremendously successful. A crop duster version of this engine was available until 1991 when it was superseded by the Magnum version. It used hydraulic lifters and a 2-barrel carburetor for most of its production, though 4-barrel Carter Thermoquad and Rochester Quadrajet carburetors were used in police applications starting in 1978. The 318 received roller lifters and a fast burn cylinder head in 1985. Throttle body electronic fuel injection was factory equipment on the 1981 to 1983 Imperial. From 1988 to 1991, another throttle body fuel injection system was used for truck and van applications. 340 V8. In the mid-1960s, Chrysler decided to produce a small block V8 specifically designed for high-performance applications. The goal was to have a lightweight, high-output engine equally suited for drag strip or street performance use. The result of this decision was the 340 Acclaim V8. Chrysler's engineers increased the 3/18 cylinder bores to 4.04 inch while keeping the 3/18's 3.31 inch stroke. Anticipating higher loads resulting from racing operation, the engineers fitted a forged shot-peened steel crankshaft instead of the cast nodular iron unit used in the 318. This also included shot-peened and forged pushrods, connecting rods and pistons. A 4-barrel carburetor was mated to a high-rise, dual-plane intake manifold. This induction setup fed into a set of cylinder heads that are still considered among the best of that era. The heads were high-flow items with big ports, and used 2.02-inch intake and 1.60-inch exhaust valves. An aggressive cam was fitted to take advantage of the much better breathing top end. 1968 4-speed cars got an even hotter cam, but it was discontinued for 1969, where both automatic and manual cars shared the same cam. The engine was equipped with hydraulic lifters and 2-bolt main bearing caps, leading some to initially underestimate the 340's potential. Power output was officially stated as 275 HP gross for the 4-barrel and 290 HP gross for the 6-pack version with triple 2-barrel carburetors. The 68-71 340's compression ratio was 10.5 to 1, placing it near the limit of what was possible on pump gasoline during that era. The 340 also used additional heavy-duty parts, such as a double-row roller timing chain and sump-mounted windage tray. In 1970, Chrysler offered a special version of the 340 that was specific to Challenger TA and Cuda AAR models. This version featured a heavy-duty short block featuring additional webbing in the block to allow for 4-bolt main bearing caps. The application-specific cylinder heads featured relocated intake pushrod passages with offset rocker arms that allowed the pushrods to be moved away from the intake ports, which could improve airflow if the pushrod clearance hump was ground away from the intake port. They featured an aluminum intake manifold with 3 2-barrel Holley carburetors and a dual-points ignition system. The best vintage road test data for these cars yielded quarter-mile trap speeds of 100 miles per hour, which suggests roughly 275 as installed HP for a car of that curb weight, using Hale's trap speed Formula 3 race weight. Contrary to undocumented claims regarding engines being underrated during that period, the 340 was one of the very few engines to be honestly rated by SAE net standards, leading many to claim that the 340 was underrated for insurance purposes. The 275-rated 340 could actually produce 257 SAE net HP and could produce 315 horsepower once all the typical for the era gross HP adding tricks were applied. By the standards of the day, one could argue that the 340 was underrated. Indeed, a multitude of vintage period road tests reveals that a 275 horsepower 340 Dodge Dart was fully capable of running toe-to-toe with Chevy's 350 horsepower 350 Corvette, which shared a virtually identical curb weight. A 275 horsepower 340 Dart was more than capable of holding its own against Chrysler's own 335 horsepower 383 big block Dart, which was only 130 pounds heavier. Due to the combination of rising gasoline prices, insurance companies' crackdown on high-performance vehicles, and the onset of inflation, the relatively expensive 340 was phased out. It was released in 1968 and remained a high-performance engine through 1971. It was severely detuned in 1972, with the introduction of low-compression small valve heads, and by mid-year, a cast nodular iron crankshaft, and a variety of other emissions-related changes. It was replaced by the 360 engine for the 1974 model year. The 340 is thought by many Chrysler diehards as having the best bore-to-stroke ratio out of all LA engines produced by Chrysler, hence why all our blocks are derived from the 340 dimensions. 360 V8. The LA 360 has a 4.00 in bore and a 3.58 in stroke. It was released in 1971 with a 2-barrel carburetor. The 360 used the large intake port 340 heads with a smaller intake valve. In 1974, with the introduction of a 4-barrel version, the 360 became the most powerful LA engine with the end of 340 production. After 1980, the 360 was exclusively used in Dodge trucks and vans. The 1978 to 1979 Lyle Red Express truck used a special high-performance 364-barrel engine with factory production code EH1, and was the fastest American-made vehicle from 0 to 100 miles per hour for those years. The EH1 was a modified version of the E58 360 police engine producing 255 HP net at 3800 rpm. Some prototypes for the EH1 featured Mopar Performance W2 heads, although the production units had the standard 360 heads. There was also a lean burn version of the 360. The 360 was replaced by the LA 360 in 1993 by the 5.9 Magnum, which shared some design parameters with the 360, however the majority of its components were different. The 5.9 Magnum was then replaced by the 5.7 Hemi. 239 V6. The 239 V6 is a 239 Acclaim V6 released in 1987 for use in the Dodge Dakota and a replacement for the older, longer Slant 6. It is essentially a six-cylinder version of the 318 V8. Output was 125 HP and 195 lb-ft until it was replaced by the Magnum 3.9 starting in 1992. In 1987 it used a two-barrel Holley carburetor and hydraulic tappets. In 1988 it was upgraded with throttle body fuel injection and roller tappets which it retained until the 1992 Magnum update. Vehicles using the 239 V6, 1987 a Euro 1991 Dodge Dakota, 1992 to 2004 Magnum Dodge Dakota, 1988 a Euro 1991 Dodge Ram, 1992 to 2001 Magnum Dodge Ram, 1988 a Euro 1991 Dodge Ram Van, 1992 to 2003 Magnum Dodge Ram Van. Interim solutions, the throttle body injected LA engines, the last variation of the LA series to be introduced before the Magnum upgrade was the 1988-92 throttle body fuel injection, roller cam engine. The first engines to receive these modifications were the 318 Sci V8 and 239 Sci V6 engines. A Holley Chrysler designed, single-point, twin-injector throttle body assembly was mounted atop a new aluminum intake manifold. An in-tank electric pump and reservoir replaced the earlier mechanical pump. The valve train was upgraded to include hydraulic roller lifters, thus allowing for a more aggressive valve lift. The resulting engine was somewhat improved as to power and efficiency, and the 5.9L V8 engines followed suit in 1989. It received much improved 308-cylinder heads. However, with other manufacturers already introducing the vastly superior multi-point fuel injection system, Chrysler Corporation considered a more drastic upgrade program. So, as the TBI engines were being introduced, the new upgrade program was initiated in the Chrysler Engineering Department. In 1992, with emissions standards becoming ever more stringent in the United States, Chrysler Corporation released the first of the upgraded engines. Magnum Engines. In 1992, Chrysler introduced the first of a series of upgraded versions of the LA engines. The company named their engine the Magnum, a marketing term that had been used by the company previously to describe both the Dodge Magnum automobile and an earlier Dodge passenger car engine series. The latter was based on the big block BRB V8 engines of the 1960s-70s. The Chrysler Magnum engines are a series of V6, V8 and V10 powerplants used in a number of Chrysler Corporation motor vehicles, as well as in marine and industrial applications. This family of gasoline-burning engines lasted for over a decade, were installed in vehicles sold across the globe, and were produced in the millions. Technical information: the Magnum engine is a direct descendant of the Chrysler LA engine, which began with the 273 Sci V8 in 1964. While the Magnum 3.9, Magnum 5.2, and Magnum 5.9 engines were significantly based on the 239, the 318, and the 360 euro respectively euro. Many of the parts will not directly interchange, and the Magnums are not technically LA engines. The only major parts that are actually unchanged are the connecting rods. The cylinder block remained basically the same. It was still a V-shaped, 90-degree design made of cast iron. The crankshaft, located to the bottom of the block by 5 main bearing caps, was cast nodular iron, and the 8 connecting rods were forged steel. The pistons were cast aluminum, with a hypertectic design. Cylinders were numbered from the front of the engine to the rear. Cylinders 1, 3, 5 and 7 were found on the left bank, or bank 1, with the even numbers on the other bank. Coolant passages were located between the cylinders. The Gerotor-type oil pump was located at the bottom rear of the engine, and provided oil to both the crankshaft main bearings and the cylinder heads. Chrysler's engineers also redesigned the oil seals on the crankshaft to improve anti-leak seal performance. The oil pan was also made from thicker steel, and was installed with a more leak-resistant silicone rubber gasket. Gasoline was supplied to the intake manifold through a pair of steel rails that fed 8 Bosch-type, top-fed, electronically actuated fuel injectors. There was one injector located in each intake runner. As such, each cylinder had its own injector, thus making the fuel system a multi-point type. Fuel pressure was regulated by a vacuum control pressure regulator, located on the return side of the second fuel rail. Excess fuel was thereafter delivered back to the fuel tank. To support the new fuel system, the intake manifold was of a new design. Known colloquially as the beer keg, or kegger manifold, the part was shaped like half of a beer barrel lying longitudinally atop the center of the V-shaped engine block. The intake runners, which supplied the fuel and air to each cylinder, fed each of the intake ports in the newly designed cylinder heads. The bolts that secured the intake manifold to the cylinder heads were installed at a different angle than those on the older LA engine. They threaded in vertically, rather than at the 45-degree angle of the 66 up LA. Air was provided from the air filter intake to the intake manifold by a Holley-designed, aluminum, twin Venturi, mechanically actuated throttle body, which was bolted atop the intake manifold. Each Venturi was progressively bored and had a diameter of 50 mm. To this unit were mounted the throttle position sensor, manifold absolute pressure sensor and idle air control valve. A steel cable connected the accelerator pedal inside the vehicle to a mechanical linkage at the side of the throttle body, which acted to open the air intake butterfly valves inside the Venturis. During idle these butterfly valves were closed, so a bypass port and the IAC valve were used to control the intake of air. The cylinder heads were another fundamental change of the Magnum engine, being designed to meet stricter requirements in both power and emissions by increasing efficiency. These heads were cast iron units with new wedge-shaped combustion chambers and high-swirl valve shrouding. Combustion chamber design was most important in these new heads. LA engine cylinder heads were given a full-relief open chamber design, but the Magnum was engineered with a double-quench closed chamber type. The higher-flowing intake ports stepped up intake flow dramatically in comparison to the original LA heads, and the exhaust ports improved cylinder evacuation as well. The shape and porting of the chambers allowed for more complete atomization of the air-fuel mixture, as well as contributing to more complete combustion. These virtues allowed for much greater efficiency of the engine as a whole. The intake and exhaust valves were located at the top of each combustion chamber. The valves themselves had shorter, 5/16 diameter stems, to allow for the more aggressive camshaft. Intake valves had a port diameter of 1.92 inches, while exhaust valves were 1.65 with 60 cc combustion chambers. Spark plugs were located at the peak of the combustion chamber's wedge, between the exhaust ports. Press-in heat shields protected them from the heat of the exhaust manifolds. Cast iron exhaust manifolds, less restrictive than units found on previous engines, were bolted to the outboard side of each head. The new cylinder heads also featured stud-mounted rocker arms, a change from the shaft-mounted LA arms. This last change was due to the different oiling system of the new engine, as described in the next paragraph. The valve covers on the Magnum have 10 bolts rather than the previous 5, for improved oil sealing. In addition, the valve covers were made of thicker steel than earlier parts, and were installed with a silicone gasket. The valve train was also updated, although it was still based on a single, center-block-located camshaft pushing on hydraulic lifters and pushrods, one for each rocker arm. However, the cast nodular iron camshaft was of the roller type, with each lobe acting upon a hydraulic lifter with a roller bearing on the bottom. This made for a quieter, cooler-running valve train, but also allowed for a more aggressive valve lift. Each of the lifters acted upon a steel pushrod, which were of the oil-through type. This was another change for the Magnum. Because the new pushrods also served to provide oil to the top of the cylinder head, the rockers were changed to the AMC style, screw-mounted, bridged half-shaft type. The new rockers also had a higher ratio, 1.61 compared to 1.51 in the LA engine, which increased leverage on the valves. In addition, the oil boss located at the end of the cylinder head on the LA engine was left undrilled, as it was no longer needed. However, the boss itself was left in place, perhaps to cut down on casting and machining costs, and to allow the use of earlier LA heads. Engine timing was controlled by the all-steel, silent Morse timing chain, which was located beneath the aluminum timing cover at the front of the engine block. The timing chain sprockets, one each for the camshaft and crankshaft, were all steel. For the last few years the LA engine came with nylon teeth on the sprockets. At the rear of the camshaft was cut a set of helical gear teeth, these being used to spin the distributor. Mounted to the front of the timing cover was a new design counterclockwise rotation water pump, with much improved flow. Externally, the accessory drive belt was changed to a serpentine system. Coupled with an automatic belt tensioner, this increased belt life, reduced maintenance and contributed to lower noise and vibration levels. The ignition system was also all new for the Magnum. Controlled by a new microprocessor-equipped single-board engine controller, the ignition system included a distributor mounted at the rear of the engine. A 36,000-volt ignition coil, usually located at the front right of the engine, provided electrical power to the center of the distributor cap, where a spinning rotor directed the power to each of the individual cylinder's spark plug wires. Ignition dwell, advance and retardation were electronically controlled by the SBEC. The SBEC controlled the ignition, as well as the opening and closing of the fuel injectors. During cold startup, wide-open throttle and deceleration, it did this based on open-loop, pre-programmed operating parameters. During normal idle and cruising, it began closed-loop operation, during which the module acted based upon inputs from a variety of sensors. The basic sensors that provided input to the SBEC included the oxygen sensor, manifold absolute pressure sensor, throttle position sensor, intake air temperature sensor and coolant temperature sensor. The basic actuators controlled by the SBEC's outputs included the fuel injectors, ignition coil and pickup, and the idle air control valve. The latter controlled idle characteristics. However, the SBEC also controlled the operation of the charging system, air conditioning system, cruise control and, in some vehicles, transmission shifting. By centralizing control of these systems, the operation of the vehicle was simplified and streamlined. Emissions output was controlled by several systems. The EGR, or exhaust gas recirculation system, brought exhaust gas from the exhaust stream up to the intake manifold, lowering peak combustion temperatures, the goal being the reduction of NOx emissions. A PCV, or positive crankcase ventilation system, introduced oil vapor and unburned fuel vapors from the crankcase to the intake, allowing the engine to reuse these as well. Furthermore, gasoline vapors that would normally be released into the atmosphere were captured by the EVAP system, to then be introduced into the engine. In 1996, the OBDII onboard diagnostic system was introduced on all passenger vehicles in the United States, as per United States Environmental Protection Agency regulation. As such, a new engine control computer was developed for vehicles powered by Magnum engines, known as the JTEC. The new powertrain control module was more complex and more intelligent, and added programming meant it could also control automatic transmission and other powertrain functions. Its firmware could also be reprogrammed via the same OBDII port. With the introduction of the JTEC, the EGR system was dropped from Magnum Engines. The 5.2L Magnum V8. The Magnum 5.2L, released in 1992, was an evolutionary development of the 318 SI-LA engine with the same displacement. The 5.2L was the first of the Magnum upgraded engines, followed in 1993 by the 5.9L V8 and the 3.9L V6. At the time of its introduction, the 5.2L Magnum created 230 HP at 4,400 RPMs and 300 lb-ft of torque at 3,200 RPMs. Production of this engine lasted until 2003, when it was completely replaced by the newer 4.7L PowerTech SOHC V8 engine. General characteristics: engine type, 318 SID 90 feet V8 OHV, bore and stroke, 3.91 x 3.31 inches, 99.3 x 84.0 m, displacement, 318 cu-in. Firing order, 1-8-4-3-6-5-7-2, compression ratio, 9.11 due to 60 cc combustion chambers of Magnum heads, lubrication, pressure feed, full flow filtration, engine oil capacity, 5.0 US QTS with filter, cooling system, liquid, forced circulation, ethylene glycol mixture. 5.9L Magnum V8. In 1993, Chrysler Corporation released the next member of the Magnum family, the 5.9L V8. This was based on the LA Series 360 SI engine, and included the same upgrades and design features as the 5.2L. The standard 5.9L created 230 HP at 4,000 RPMs and 330 lb-ft at 3,250 RPMs. It was upgraded in 1998 to 245 HP at 4,000 RPMs and 335 ft-lbs at 3,250 RPMs. However, Chrysler came out with the performance-oriented RT version in 1998. This engine was provided with a more aggressive camshaft profile, and it was rated for 250 HP and 345 lb-ft. The 5.9L RT came factory-installed in 1998 to 2001 Dodge Dakota RT pickups and Dodge Durango RT SUVs. It was also installed in the Jeep Grand Cherokee Limited 5.9, only available in 1998. The 5.9L Magnum was available until the 2003 model year, when it was replaced with the 5.7L Hemi V8 engine. Although the pre-Magnum and Magnum versions of the 360/5.9 are both externally balanced, the two are balanced differently and each requires a uniquely balanced damper, flywheel, drive plate, or torque converter. Bore size was 4.00 inches, stroke was 3.58. Compression ratio was 9.1 to 1. Magnum 3.9L, as the 5.2L V8 was introduced in 1992. The often forgotten V6 version of the Magnum engine became available in the Ram pickup and the more compact Dodge Dakota. Based on the LA Series 239 SI V6, the 3.9L featured the same changes and upgrades as the other Magnum engines. The 3.9L can be better understood by imagining a 5.2L V8 with two cylinders removed. Power increased substantially to 180 HP at 4,400 RPM A&D from 195 lb-ft to 220 lb-ft at 3,200 RPMs, as compared with a previous TBI engine. For 1994, horsepower was reduced to 175, mostly due to the installation of smaller volume exhaust manifolds. Torque ratings remained the same. For 1997, the 3.9L engine's torque output was increased to 225 lb-ft, with a compression ratio of 9.1 to 1. Firing order was 1-6-5-4-3-2. This engine was last produced for the 2003 Dodge Dakota pickup. Starting in the 2004 model year, it was entirely withdrawn from production and replaced with the 3.7L PowerTech V6 engine. 8.0L Magnum V10, as the design for the 5.2L Magnum V8 was coming together in 1988, consideration was given to the design of a larger V10 iteration, mainly intended for use in Dodge Ram 2500 and 3500 pickups. This was to be Chrysler's second 10-cylinder engine, and can best be understood as a 5.9L V8 with 2 cylinders added. This 488 cubic inch engine was based on a cast iron block, and was rated for 310 HP at 4,100 RPMs and 450 lb-ft torque at 2,400 RPMs. Bore was 4.00 inches and stroke was 3.88. Compression ratio was 8.4 to 1. Firing order was 1-10-9-4-3-6-5-8-7-2. Valve covers were die-cast aluminum, rather than stamped steel. This lowered noise levels and made for better gasket sealing. The 8.0L Magnum V10 first became available in the 1994 model year Dodge Ram 2500 and 3500 pickups, and it was the most powerful gasoline-burning engine then available in any passenger pickup truck. The engine lasted through the 2003 model year, after which it was discontinued. Magnums today, Chrysler offers a line of crate engines based on the Magnum designed to bolt into older muscle cars and street rods with little modification. Some of the changes to facilitate this were using a 1970-93 water pump so that older pulleys and brackets could be used, as well as an intake manifold that uses a carburetor instead of fuel injection. With a high lift cam and single-plane intake, the crate Magnum 360 was rated at 380 HP with the Magnum heads. Later models equipped with RT, or aluminum cylinder heads produced 390 HP. A 425 HP bolt and fuel injection conversion kit is also available. Identifying a Magnum engine, the easiest way to differentiate a bare Magnum block from a LA is by checking for the presence of the two crankshaft position sensor mounting bosses on the right rear top of the block, just to the rear of the cylinder head deck surface. Bosses equals Magnum. All Magnum engines were stamped with a unique engine ID number. This was located on a flat impression on the cylinder block's right side, near the oil pan gasket surface. From 1992 to 1999, the ID was 19 digits long. An example would be 4M5.2LTO4231234567. The 4 is the last digit of the model year of the engine. This example is a 1994. The M stands for Mound Road, the plant where the engine was assembled. Other characters found here would be S for Saltillo, T for Trenton and K for Toluca. -5.2L has an obvious meaning here, the displacement of the engine in liters. The seventh character, here a T, was the usage of the engine. T translates to truck usage. 0423 would mean the engine was produced on April 23. The final 8 digits, here shown as 12,345,678, are the serial number of the engine. From 2000 to 2003, the engine ID was shortened to only 13 characters. It differed in that engine displacement was given in cubic inches rather than in liters, the usage character was dropped and the serial number was 4 instead of 8 digits long. To add some confusion, not only was the name Magnum used on Dodge Pasca Hypo engines 1967-70s, and vehicle lines in the late 70s and 2000s, it was also applied to the first year of the 5.7L Hemi V8 in pickup trucks. See also, Viper engine, Chrysler engines, Chrysler A engine, Chrysler Hemi engine. References, ABCDEFGH Mopper LA engines. 1. Car and driver, the Dodge Lear Euro unregistered trademark L Red Express truck Olpa. Retrieved April 21, 2013. A. ABCDEFGHIJKLM 5.2L engine specifications, ABCDEF Magnum engine features, ABCDEFGHIL Shepherd and M. Gindrella, Magnum Engines, Chrysler Corporation, 2000, ISBN, L. Shepherd and M. Gindrella, Jeep Engines, 3rd edition, Chrysler Corporation, 2000, ISBN, ABCDE Magnum cylinder heads, ABCJ Haynes and M. Stubblefield, Automotive Emissions Controls, Thomas Delmer Learning, January 1999, ISBN 978-1-85010-667-8, J. Haynes and B. Henderson, OBDII and Electronic Engine Management Systems Textbook, Thomas Delmer Learning, March 2006, ISBN 978-1-56392-612-9, ABC Magnum 5.2, Magnum 5.9L, 2, the 3.9-liter LA Series Dodge V6 engine. AB 5.2L V8 specs.